The inverse function property says that the f function evaluated at f inverse of x is equal to simply x, and the f inverse function evaluated at f of x is equal to x. Those two things imply that f and f inverse are inverses of one another. And it works the other way. It's a double arrow. If you know that f and f inverses are inverse functions of one another, you know when you compose them together and evaluate x, they obliterate one another and just leave x. So the question is, are the functions f of x equals x cubed minus 1 and g of x equals the cube root of x plus 1, are these inverse functions of one another? To check, step 1, we'll check that f composite g of x is simply equal to x. We're trying to show that the composition is just equal to x. Let's evaluate it. This is equal to f of g of x, so it's f of the cube root of x plus 1. Okay, the f function says, whatever you feed me, cube it and subtract 1. So we're going to cube this cube root and then subtract 1 on the outside. The cube and the cube root cancel each other. We get x plus 1 minus 1, which is x. Yes, it worked in that direction. Now step 2, the other direction. The question is g composite f of x simplifying to x? Let's see. G composite f of x is g of f of x, which is g of, okay, what was the f function? It was x cubed minus 1. Now, what does the g function say? It says, whatever you feed me, take the cube root and add 1 to the value you feed me. Okay, so it is the cube root of what we fed it, x cubed minus 1 plus the 1. The 1's cancel, we get the cube root of x cubed. They cancel, the cube root and cube, and we get x. So in both cases, we were able to simplify all the way down to x, and that implies that yes, they are inverse functions of one another. Nice.